In this video, we will demonstrate how to use a solubility table. Using a solubility table to determine the solubility of ionic compounds is very important. It can tell you whether or not your compound will dissolve in water or whether it will remain a solid. It is also useful for determining which one of your products in a double displacement reaction is going to precipitate. Now, solubility in aqueous solutions is dependent entirely on water's power to break apart the ions in your ionic substance. This is the solubility guideline that either you will be given or you will have to memorize. You will have to ask your instructor as to what is expected of you. Now, how do we use this table? Well, for example, if we're given calcium iodide, we would look up either one of these ions and see if we can't find them in one of these categories. Calcium is not listed under soluble or insoluble compounds, but iodide is. Iodide compounds are generally soluble. There are a few exceptions, but calcium iodide is not among them, so calcium iodide is considered soluble. Lead iodide, on the other hand, is insoluble. Again, iodides are generally soluble, but lead 2 iodide, along with silver and mercury 1 iodide, are exceptions. So this is insoluble. Given sodium fluoride, you would look up either sodium or fluoride. Now, fluorides are generally considered insoluble, but if you look at the top of the table, you notice that compounds in group 1, sodium, lithium, and so forth, those are all considered soluble. So sodium fluoride is definitely going to be considered soluble. Calcium fluoride, on the other hand, well, again, fluorides are generally insoluble. There are some exceptions, but calcium fluoride is not among them. So calcium fluoride is insoluble. Now take magnesium hydroxide, for example. Hydroxides are generally insoluble, and again, check the exceptions. If there's an exception to the insolubility rule for hydroxide, then it would be soluble, but magnesium is not among them. So magnesium hydroxide is insoluble. Potassium hydroxide, well, again, all group 1 metal-containing compounds are going to be considered soluble. There are essentially no exceptions. So this hydroxide is actually soluble. Ammonium sulfate, well, we can look up either ammonium or sulfate. We see that sulfates are generally soluble, except paired with silver, calcium, strontium, barium, lead 2, and mercury 1. But ammonium, all ammonium compounds are considered soluble. And finally, barium sulfate. Again, sulfates are generally soluble, but as we said before, barium is an exception. So barium sulfate as well as barium sulfite are both going to be insoluble. Practice with these. I will reveal the answer to each one of these 5 seconds at a time. Pause the video if you need to. Did you get them? Good. And lastly, the solubility table can be used to help us predict the products in a double displacement reaction. Now, if we were to take silver nitrate and sodium chloride and mix them in solutions, we would get a double displacement products of silver chloride and sodium nitrate. But which one is soluble and which one is insoluble, if any? Well, we know that all nitrates and all group 1 metal ions are considered soluble. So sodium nitrate, that's definitely going to be soluble. Silver chloride, on the other hand, according to the table, is insoluble. So we would write this reaction: aqueous silver nitrate plus aqueous sodium chloride go to make solid silver chloride and aqueous sodium nitrate. Another example, lead nitrate and sodium sulfate. What are the double displacement products for this reaction? That's right, lead sulfate and 2 sodium nitrates. Are either one of these products insoluble in water? If they are, we would write a state of matter of S for solid for them, and the other one would be aqueous. There can be two solid products, but that's very rare. Did you get them? That's right. Lead sulfate is insoluble, and again, as above, sodium nitrate is soluble. So we would write this equation: aqueous lead nitrate plus aqueous sodium sulfate go to make solid lead sulfate, and 2 sodium nitrate, aqueous.